exercise 2.3. Divide the polynomial p of x by the polynomial g of x and find the quotient and remainder in each of the following. Okay. So in the question, what they are saying, they are giving two polynomials p of x and g of x, and they want us to perform division process, and we have to find what is the quotient and what is the remainder in each of the following. Okay. First problem. P of x is equal to x cube minus 3x square plus 5x minus 3, and g of x is equal to x square minus 2. Okay. So here the dividend is cubic polynomial and the divisor is a quadratic polynomial. Okay. So before starting division process, we are always taking divisor on left side and dividend in middle and coefficient on right side. Okay. So I am taking x square minus 2 as divisor and x cube minus 3x square plus 5x minus 3 as dividend, and we have to find coefficient and remainder after doing division process. Okay. First step, we have to identify what is the highest power of x that is present in divisor, that is x squared. Now, in the dividend, what is the highest power of x? That is x cube. So, if I want to make x square into x square as x cube, then I want to multiply with x, and this x is taken as coefficient. So, x into x square, that is x cube, and minus 2 into x, that is minus 2x. Okay. Then, after multiplying, what we have to do? We have to change the symbols to its alternative. That is, positive term can be replaced with negative term, and negative sign is replaced with positive sign. Then we are getting plus, minus, and plus. Okay. Now we have to perform addition. So while addition, x cube minus x cube get cancelled, and 5x plus 2x get 7x. So when we borrow to down these two terms, we are getting the resultant expression as minus 3x square plus 7x plus minus 3. Okay. Again, we have to check what is the highest power of x term present in divisor, that is x square, and what is the highest power of x term present in the dividend, that is minus 3x square. Here it is x square and it is minus 3x square. So if you want to convert x square into minus 3x square, we want to multiply with minus 3, and it is taken as coefficient. So if we multiply with minus 3, we are getting minus 3 into x square, that is minus 3x square, and minus into minus plus 3 into 2, that is 6. See, I am writing x square term under x square and constant term under constant, and if there is any x term, I can write x term under x term. So you also must follow to write the same manner. Why? Because if you write x term under x square term, then while getting addition, we are getting a chances of doing mistakes while performing division. So be careful. We should always remember we should write x square term under x square term and coefficient term under coefficient term. Okay. Now, after multiplication, we have to change the symbols to its alternatives. Okay. Now, again, after performing addition, minus 3x square and plus 3x square get cancelled, and minus 3 minus 6, resultant is minus 9, and this 7x get borrowed down. So the resultant expression is 7x minus 9. Again, we have to check what is the highest power of x term present in the divisor. It is x square. Now, the highest power of x term present in the division, that is 7x. Here, we can clearly see that the degree of divisor is 2, and the degree of divisor and the degree of dividend is 1. That is, the degree of divisor is greater than the degree of dividend. Hence, we have to stop this division process. We mainly stop the division process at two cases. One, when we obtain the remainder as 0, and in the second case, when we found the divisor having a higher degree when compared to dividend. So here we have to stop the division process, and we take 7x minus 9 as remainder and x minus 3 as a quotient. Okay. Second problem, given p of x is equal to x power 4 minus 3x squared plus 4x plus 5, and g of x is equal to x squared plus 1 minus x. Okay. Now we have to perform division operation. We have taken divisor on left side, dividend in middle, and quotient as right side. Okay. Now I am taking x square minus x plus 1 as divisor and given polynomial as dividend, and we have to find quotient and remainder. Okay. In the first step, we have to check what is the highest power of x term present in the divisor. Here I can clearly say that x square is the highest term present in the divisor. Next, we have to check what is the highest power of x term present in the dividend. Here we can clearly say that x power 4 is the highest power term present in the dividend. So in order to convert x square into x power 4, we have to multiply x square with another x square. So if you convert x square into x power 4, then after changing symbols, we can perform addition to eliminate this term. So I want to multiply this total divisor with x square. Then I get x square into x square, that is x power 4, minus x into x square, that is minus x cube, and plus 1 into x square, that is x square. See, here in the given polynomial there is no x cube term, but we are obtaining x cube term so that we can make it separate, and while performing next step we can include this as the highest power. Okay. So now I want to change symbols. So plus can be changed into negative and negative can be changed into positive. Now we have to perform the division process. While performing addition process, we can notice that plus x power 4 and minus x power 4 get cancelled, and now minus 3x square minus x square, that is minus 4x square, and here plus x cube plus 4x plus 5. Okay. Now again we want to check what is the highest power of x term that is present in the divisor, as well as what is the highest power of x term that present in dividend. But here when we observe this case, here the power of x is not in a proper order. So we can arrange this equation into a proper order by placing the descending order of powers of x. So we get x cube minus 4x square plus 4x plus 5. Okay. Now we can check what is the highest power of x term present in the divisor, that is x square, and what is the highest power of x term present in dividend, that is x cube. So I want to convert x square into x cube by multiplying it with x. Then I getting x into x square is x cube, and x into minus x, that is minus x square, and x into 1, that is x. So again I want to alternate the symbols, that is positive can be changed into negative and negative symbol can be changed into positive. Then we have to perform addition. Then we get x cube minus x cube but cancel, and minus 4x square plus x square, that is minus 3x square, and plus 4x minus x, that is plus 3x plus 5. Again now we have to check what is the highest power of x term present in the divisor. We can clearly say that x squared is the highest power of x term present in the divisor. And coming to the dividend, the highest power of x term present in dividend is minus 3x squared. So if we want to get x squared converted into minus 3x squared, then I want to multiply x squared with minus 3. So minus 3 is added to coefficient. Now x squared into minus 3, which is equal to minus 3x squared, and minus of plus 3x and minus 3. So again I want to change symbols to its alternatives. Then I am getting, by summing these terms, 3x squared minus 3x squared get cancelled, and plus 3x and minus 3x get cancelled, and 5 plus 3, that is 8. So I am getting 8. Now again I want to check what is the highest power of x present in divisor, that is x squared. And now what is the highest power of x present in dividend, that is x power 0. So we can clearly say that here the degree of divisor is greater than the degree of the dividend. Hence the division process can be stopped, and we have to take this as a remainder and this as a coefficient.